Hi, my name's Luke, and today I'd like to tell you about dotmesh. It's a new project that we're launching today, and it's all about bringing data into the circle of control. But before I tell you about the circle of control, let me paint a picture. So we're all software developers. We know what a bad day at work looks like. And there are a few specific scenarios that we've learned about by talking to dozens and dozens of software developers and operations people that describe how things can be bad at work. And one of the first ones is when you're trying to deploy some software, it passes the tests in CI and then it blows up in production. And why does it do that? Because production is different to all your other environments. It's different because the data in production is different. It's different because the scale of production is different, or maybe just because the inputs to production are different. There's different amounts of traffic, different levels of load, and so on. So deploying software that worked in dev, test, and CI and blew up in production is a very real problem that affects most companies all over the planet. The second problem is I've sort of modified an XKCD here to describe the problem, is that CI slows development teams down, and you often have to ask the question, why are development teams slow? Lots of companies I've worked at have the problem that they just can't seem to get stuff out. And when you dig into what the problems are, there's often a slow CI system at the heart of the situation. And so there are certain types of tests that are often slower than others. There's specifically end-to-end tests that have to set up database state across multiple microservices. These are either slow and flaky, or they're hard to get right, so you don't have them. And that, of course, leads back to problem one, where you don't have sufficiently realistic testing, so you get problems in production. And then the third problem that we've seen is that you do not simply capture the state of 4 microservices at once. The explosion of microservices is causing what's known as polyglot persistence, which is that each microservice has its own data store. And so even if you've managed to reproduce a critical bug locally in an environment where you've got 4 microservices running, it's hard to capture that state and share that with your colleagues. So what we're seeing here is that there's problems at all stages of the software development lifecycle. There's problems in prod, where you have these unexpected production outages because the tests aren't realistic enough. You have problems in CI and testing, where you're trying to manipulate real databases, but it's slow. And then once you've got those real databases in your tests, capturing those failures is hard. And then in development, capturing and sharing development states is just hard enough that no one does it. Now, what went wrong in all of these cases? If you sort of try and zoom out and think about what it is that's common to all of these problems, you discover that it's about not being in control of data. Now, modern software development is all about control. It's all about bringing things into what I call the circle of control. Version control and, so if you take a second to think about what is your application made up out of? Your application is made up out of code. It's made up out of infrastructure, servers and load balancers and disks. And it's made up out of data, which is the actual data that's stored in the application. Now, immutable infrastructure got our, version control and automated testing has moved our code into the circle of control, both the code itself and the set of inputs that it's subjected to when you validate it in CI. So tools like Git, like Jenkins, GitLab, Travis, etc., they're all helping us bring code into the circle of control. Immutable infrastructure has made our IaaS resources and the state of our application servers controllable and sane. So tools like Terraform, Ansible, Docker, and Kubernetes, they're all about dealing with declarative configuration to cause infrastructure to get formed into a certain shape. But dealing with data is still largely a collection of manual processes, scripts, and black magic. And so our mission at dotmesh is to fix that and bring data into the circle of control as well. And by doing this, we complete the circle and we make it possible to unlock a bunch of workflows that weren't possible before. So that's the big picture. That's the motivation. But then how do we do that? How do you bring your data into the circle of control? And what I'm proposing today is that the way that you do that is with a mesh. And so you have a mesh that looks a little bit like this. And once you have a mesh, you can do lots of cool stuff. So I'm going to show you what you can see here is you've got a mesh. You've got a mesh with .hub at the center, and then you've got various different stages of the software development lifecycle as environments around the mesh. So you have one developer's laptop, another developer's laptop or VM. You have your CI system, you have a staging system, you have production. Now, the very first thing you can do with the mesh is that you can share some data between some developers. So suppose developer one creates some data locally. You can capture, as part of debugging an application, you can capture that state as a data dot, and then that developer can push that state to the .hub, and another developer can pull down that state in order to reproduce exactly the same environment that the first developer had, databases and all, between two different development environments. Now, that means that if there's a difficult to debug problem, you don't have to get someone to come over and look at your machine or give them SSH access anymore. You can just capture and share the state of the entire environment and share it via the .hub. So that's just the first thing you can do. The next thing you can do is you can capture failed CI runs. So this is just another example of moving data around in the mesh. So you can take the state of a failed CI run after it's run in the CI system. That might be an end-to-end test that involves multiple different databases as part of your microservices acceptance tests. And you can take that dot, you can capture that dot that captures that application state and take it from CI and pull it down onto a developer's laptop, for example, so that they can diagnose the failure in CI without having to block everyone else making progress. You don't have to stop the world and SSH into the CI server to go and poke around anymore if you can't fix a problem that you found in. You can't fix a problem based on just looking at the logs in the CI server. There are other things you can do as well. Once you have a mesh, and this is now talking more about things that we'll enable in the future, but you will be able to take realistic data from production. So for example, you'll be able to capture a data dot that captures the entire state of your production system, pull that into the .hub, perhaps on an hourly or daily basis, and then scrub that data and make it available on demand to all the developers who might need it to run CI jobs or run tests against. You can also pull it down into your staging environment, for example. So pull it down into CI to run tests, pull it down into staging to make it available to developers. You could even have a series of environments and have each one automatically, so you could have dev, staging, pre-prod, prod, etc. And you could automatically update each environment with representative data from the n+1th environment on a schedule. So this is the big vision for what we are building. And today we are announcing, or we're previewing, three things. The first one is a new company. So Subtree Inc. Has $10 million of seed funding to build the mesh. We're currently a team of 8 lovely people. We're announcing 2 new products. The first one is dotmesh, which is an open source utility that lets you capture, manage, and share your entire application state in these units that we call data dots. And we're announcing .hub, which is an online centralized repository that allows you to pull and push data dots for safekeeping and collaboration. I'll go into more detail about those in a moment, but first let's ask the question, what is a data dot? So data dots are these things that you can pull and push and move around. The first thing to point out about a data dot is that it's not a small thing. It has internal structure. And you'll be able to see, for example, that you can have a data dot here which captures the state of a Mongo database and a MySQL database. So you might have a master branch for that data dot, and from a branch you can make commits, and commits are just like commits in Git. So they allow you to take sort of an atomic snapshot of the state of a Mongo database and a MySQL database that might be attached to a microservices app that has this polyglot persistence I mentioned earlier. You then notice that you can have multiple commits that capture different states of this. You can also create different branches. So in this commit here, we created a branch off that previous state and created another branch called new branch, and then carried on modifying it over here, maybe to reproduce a specific bug based on some initial starting state. And of course, with a data dot, you can also push and pull it. So this is a local data dot that might be running on a developer's laptop. Here is a remote data dot that is running up on the dot hub. And so this user Alice could do dm push to push this data dot, and it would push all the snapshots that are needed to reconstruct this data, sort of as all the transitive dependencies of these snapshots up to the dot hub. So dotmesh 0.1 is a Git-like CLI for interacting with data dots. The CLI is called dm, and then there's also dotmesh server, which is the server-side component for storing data dots. You can run it on just one server on your laptop, or you can run it in clustered mode. It supports running across multiple machines and aggregating the storage across a cluster of machines. It has a Docker volume plugin and support for Docker Compose, and it also supports Kubernetes, persistent volumes, persistent volume claims, and dynamic provisioning. Like I mentioned earlier, you can make commits for atomic snapshots of your data, subdots to capture your entire application state in one commit. Subdots are basically separate sort of partitions of a dot for different data services, like we saw earlier, MySQL and Mongo. And then you can have branches that let you sort of fork your data and build up a library of states. You can, of course, push to and from the dot hub or your own dotmesh clusters, and there's more information on dotmesh 0.1 on our docs. And then we also run this nice SaaS platform called dot-hub for you. So we're offering to store your data dots for you and look after them. It's basically just a namespace dotmesh cluster that we run with collaborator support. It's got a nice web interface for API keys and stuff. It's got a 1 gig free tier, and after that it's $10 a month for 5 gigabytes of storage. And then I just wanted to define sort of a big picture roadmap, which is that at the beginning where we are now is that we're just defining the mesh, and we've got sort of version 0.1 software that does some of the things that we want to be able to do that I've sort of painted in the picture that I described earlier. The next things that we need to do after this are to bring production volumes into the mesh so that you can have failover, for example, on your dotmesh volumes in production or pre-production environments. We want to be able to bring production databases that are outside of the likes of Kubernetes or Docker and ingest them into the mesh. And in the future, we might even also support bringing production traffic into the mesh, because that's one of the things that we heard people tell us when we talked to lots of people at the end of last year, was that actually the inputs to their system are just as important as the data that's held inside it. That's sort of broadly our roadmap. We're here. We're just at the beginning stage of defining the mesh, and we hope that you'll join us on the journey. Please try it. Please give us feedback. We are really, really hungry for feedback, and your feedback is really important to us. So either email me, tweet at us, or come and join our Slack. Thanks very much.